It's quite a long time now since the last SuperHouse episode was uploaded. That's for a whole variety of personal reasons that I won't get into right now. And I've actually been working on a whole lot of them at the same time. I have about 5 episodes that are at least partly filmed and edited. It's just for various reasons, none of them have got to the point where I could upload them. They should be all uploading quite soon though, so there's more SuperHouse to come. While working on those episodes, I've had to put together a whole lot of circuit boards, which has meant a whole lot of surface mount assembly. I have a toaster oven which I've been using for many years for doing reflow on circuit boards. So it says not for food, poison, lead and flux. That's because what I do is put surface mount parts on circuit boards, put them in the oven, and then I've got an Arduino down here which is connected to it, which turns it on and off. There's a temperature sensor in the back. If we come down the back, you can see the probe sticking through. I just punched a hole in the back of the case, put the temperature sensor through, and the Arduino has an output that controls this power board back here. So what it does is maintain the correct temperature profile for doing reflow of solder. You put the boards in, press the start button, it heats up to the correct temperature, holds it, and then cools it down. And I even messed around with it and put a servo on the front here, so that attaches to the door, and then once the reflow part is finished, it turns the oven off and it moves the servo and it pulls the door open so that it'll cool down quicker. That's worked really well, and I've actually run probably a couple of thousand boards through this oven. The problem is that the heating isn't very even inside it, and yeah, it really just doesn't follow the profile very well. So I thought it was time to go for something a bit better. And also I've got a production run coming up where I need to do a few hundred of a certain board. So I thought it was time to get a proper reflow oven. I don't even know how to open this thing. I hope I've got it up the right way. It's not upside down. Let's just get into the box and hope I don't damage it. Well, certainly very well packed. Can't fault them for how they've done that. It was packing inside packing. And there were even a couple of bits of wood on the outside of the cardboard box. I took those off before I started filming. And then all of that was wrapped in plastic as well. So it's arrived in mint condition. Now I've got to clear some space here on the bench to put it in place. I'm going to put it basically where the old one was, or it currently is. One of the things I don't know about is what sort of fumes I'm going to get out of this. I've got an exhaust system with a big bit of conduit that runs all the way around the workshop, and there's a T-piece just down under here somewhere. What I might end up doing is running the exhaust duct up to pull the air away from the oven, because flux fumes and things like that are bad. I may even end up having to put a cover over it, or maybe put it out in the back of the garage. We'll see what happens. I'm going to open this up and just make sure that the internal wiring is sensible. I bought so many tools and various things from China that have been wired in a very strange way, like they might have earth not connected properly, or they might have switched active and neutral, or all sorts of stupid things like that. So whenever I get a piece of equipment like this, first thing I do is open it up, have a look inside and make sure all the wiring is sensible. Once I opened this up, I noticed that despite their excellent packing job, the bottom corner, can I get some focus, has actually had a bit of a ding on it. Having trouble. Basically classic corner damage. It's not going to affect it in any way, but it's disappointing that it's actually got that mechanical damage to it. Oh well, you can only pack things so well. Eventually, if something gets dropped on its corner, it's going to take damage no matter how well you've packed it, particularly when it weighs 25 odd kilos. Now, interestingly, once I got it open, I discovered that pretty much all of the wiring is inside the top little part of the box. So what you can see here is the bottom of the controller. Field of view isn't quite right. Hang on. That's better. Okay, so now you can see the bottom of the control box, which is visible on the top part of it. The main body of the oven has almost no wiring in it at all. Now I assume that these are thermocouples, these two things coming through here for temperature sensing. A couple of silicon sheath cables running down the back, and another big silicon sheath cable going through there. And this is all insulation underneath. It's like the bats you find in house insulation. If you pull this up a little bit, it's all like fiberglass bats. So the only electrical that goes down into the main part of the body of the unit is heating and fans and temperature sensing. So everything that matters is going to be inside this control unit, which sits up here on top. Now that I've got the screws out, we can have a look inside the controller. And I've got to say that the build quality of this is better than I expected. It's really good. So they've got good connectors on here. They've gone to the trouble of heat shrinking things where it should be heat shrunk. Good quality things in here. The earth connection has got like a little binding strap that goes across to the case. And up under here you can see there's the controller itself, which does the logic. This is the back of the display, the buttons down here, and then the connections that go out to the temperature sensors and control of the heating elements and all of that sort of thing. Now, one thing that they haven't done, and I often am a little bit paranoid about this, is adequately bridge the ground connection through to the main part of the case itself. So the ground connection that comes in is tied by an earth strap to the metal here, but what you can often find is that if you screw something together, the screw itself, because this is anodized or painted or something, may not make good electrical contact. The threads probably will, but then the head won't necessarily. So what I'm going to do is add a little earth strap that goes down to the main body of this as well. I can see that all of this is all nicely earthed, but the main body may not be. And I can do that very easily just by putting a little binding onto this screw here, which goes through into the main part of the chassis, and run a strap up to the earth connection. That'll make sure this is all safe. Overall though, I'm very impressed. Looks like a good quality build. So just to demonstrate what I mean about the earthing problem, this is the earth connection on the cable here, and I've just got continuity mode set on the multimeter, so you can hear the beep if there's a contact. Now the cable comes in through the back, and as I said, it's got that earthing strap that ties it to the back panel. If I touch that screw head, you can see that screw head is earthed. This one is not, because this screw goes into the back panel where the earth strap is, but then there is no connection between that back panel or these screw heads and this bit of metal, and then subsequently onto these screws here. And that also means if I touch one of the other screws around on the main body, I get nothing. If I touch bare metal in the drawer slide, I get nothing. So I want to make sure that this is all earthed. So I need to pull it back apart and put that earth strap in place. A bit of quick investigation showed that I could achieve the same thing just with a little strap between one of the screws that's connected to the earth internally and a screw connected to the case. So now with the continuity set to the earth connection there, I can touch any of these screws. I can pull the drawer out, touch the body. Basically it's all earthed all over, so that should be safe now. If anything goes wrong, that'll be enough to trip the earth leakage circuit breaker in the house, and I'll be fine. Now before I set this up and start using it, I'm going to make sure that it's level. One of the issues that I had with the little toaster oven was that the tray inside it was kind of rickety, and it meant that things wouldn't sit flat. And what would happen is that the solder would reflow, and sometimes it would end up pooling slightly towards one side of the board or the other. So you might have a row of resistors, and the pads on one end will have more solder on them than the pads on the other. I want to make sure this is sitting totally flat, because it's much more structurally rigid than the little toaster oven, if I get it flat, it should stay flat. It should be good. So what I'm going to do is use a couple of old leftover circuit boards, just things I'm never going to use, and chop them under the legs, use the spirit level and get it all perfectly level. It's pretty well level left to right at the moment, so I've already chopped under this side, but it looks like it's tilting back a little. I need to bring the back up, so I'm just going to chock the back feet with a couple of PCBs, 1.6mm PCB. Should give it just the right adjustment so it all sits flat. So now it's sitting dead flat, both left to right and front to back. I had to put 3 PCBs under the back and 1 PCB under this front corner, and that's all got it just right. Now this is actually pretty straight. The problem is that this bench isn't straight. It's got a bit of a sag in it, and that's what I'm compensating for. If this was going on a nice perfectly flat bench, you could just plop it down and it'd be ready to go. Now before I put any real boards through it, I'm going to do a bit of a test. This is some leftover PCBs from modules that I'm never going to use. What I've done is just chucked some 0603 parts. There are 2 resistors on each of these boards, and there's a 4004 diode. I wanted to test something which has got a bit of mass to it and a couple of small parts. So what I'm going to do is distribute these around the tray and then run a reflow cycle, and I'm going to see how it goes, like see if we get the same results all the way across it. Now we have the boards in the tray. I got them distributed around because I want to make sure the heat is even. If these all come out looking the same, then we're good. Now that really annoying whine you can hear is from the cooling fan for this controller. I don't even know if that's going to be needed, but we'll see. I might end up disconnecting that fan because it's going to drive me nuts otherwise. So we've got, I assume that this is to change it into Chinese language mode, but it comes up with English menus by default. It's got status lights for fan and lamp. Lamp is actually the heater, I've discovered just by experimenting with this. So the extraction fan is what it uses to blow the hot air out once it's finished the heating part of the process, and lamp just shows you when the heater itself is running. So we've got function 1, 2, 3 and 4, 1, 2, 3 and 4, and S or select. It's turned on. It's not an illuminated button, so we can't really see obviously when it's on, other than that annoying noise and the LCD. So temp wave auto execute, manual execute, temperature wave select. So F3, I'm going to select the wave profile, and it shows here a little chart of what's going to happen with the temperature, and you can edit these I think as well. So F1 and F2 to go left and right, so F1 to go to the right, which is on the left, and F2 to go to the left, which is on the right. Very confusing. So we'll go to the right by pressing the left button, and now we've gone to wave 2, wave 3, wave 4, 5, 6, 7 with an asterisk against it. I don't know why that is. 8. This particular curve looks much more like what I would expect from a normal preheat. So it's like a heat, soak, spike, cool, which is the 4-stage classic reflow profile. That's pretty much the profile that I've been using on my little toaster oven, and I might give that one a try. And then back to wave 1. Okay, so we've got 8 waves in total. Wave 1, that actually looks like it would kind of make sense as well. So if wave 1 is the default, I think I'll give that a try. So F4 for OK. Oh, it's quite a slow response on these buttons. The controller doesn't seem to be scanning the buttons very frequently, so often you just press it quickly and nothing happens. So you have to sort of press it and be deliberate about it. So manual execute, I don't know what any of this means, but let's just try F2, manual execute, and we'll see if it runs. Oh, look at this. So now we have a temperature chart. No, it's not following the wave pattern. It looks like this is just a way of being able to increase and decrease the temperature manually, or stop it. So F1 to increase the temperature, F2 to decrease, I think. Yep. Oh, the fans come on now. Who knows what's going on here? I'm just going to hit stop to get out of that. temp wave auto exec. Let's try that one. Wave 1, and that's what was selected. And now we can see that the lamp has come on, which is actually the heater. So it will now have started heating up inside here. We can see the temperature which the curve says it should be. So it's currently saying that it should be 51C, 52C and going up. The actual temperature is 27, so it hasn't really started getting hot yet. 28. So the real temperature is lagging behind the profile temperature. It's not keeping up with it. But, well, we'll see how it goes. Well, the oven is now 3 minutes into its cycle. It's up to 158 degrees on the inside and climbing. And on the outside, it's actually stone cold. This is, like, feels cold to the touch. It's just like room temperature. The insulation on this is actually really impressive. Inside that oven, well, it's now 163 degrees and climbing. And if you touch the outside, you would swear it's not even turned on. There's so much insulation in there that it's doing a really good job of keeping the heat contained. That's impressive. I like that. And you can see here on the temperature chart that it didn't quite ramp up as quickly in the heat part, but then in the soak it caught up to it, and the expected temperature is now pretty close to what it should be. So the reality is following fairly close to the curve. It's close enough that I'm not worried about it. So it's heading towards 200 degrees now, 185 Celsius right now and climbing. It's now up well over 200 degrees, 212, 213, still climbing, but it's very shortly going to get to its cool down part of the cycle. And what we should see is the lamp turn off, which is the heater, and the fan turn on as it dumps all the hot air out of there and tries to bring the temperature back down again. So let's just see what happens. And even now, after it's going on 5 minutes into its cycle and it's over 200 degrees internally, the outside of the case still feels stone cold. You wouldn't know it was turned on. As you can see, the lamp is now turned off, the heater, and very soon it will start cooling it down. It's now started active cooling, so we'll see the temperature fall quite rapidly. It's now at 209 degrees, 206, 202 and coming down. In fact, it was falling a bit too fast. If you look at the curve on here, it undershot the cool down curve. So you can see that it's modulating the fan. It's turning it back off again in order to maintain the correct rate of cool down. It doesn't want to cool it down too quickly and brings it down at a controlled rate. And this cool down curve here should follow the predicted curve. Now it's in the cooling cycle and it's working hard to dump all the hot air back out again, bring the temperature down. The top of the unit still feels pretty cold. Like, I can feel a bit of warmth now. It's seeping out because the fan is running. It's forcing the air out through all the cracks. The air is tending to come out around the bottom, pretty much none at the back. What the fans are doing is sucking it in. There are two big fans in the back. They bring the air in from the back, blow it down, and then it's coming out through the bottom on the sides and at the front. So when you set one of these up, you need to make sure that you have it in an area where the hot air being evacuated from it is not going to be a problem. And of course, fumes could potentially be a problem as well. I haven't smelled anything yet, which is good, but I'm probably going to need extraction to make sure that I'm not sitting here breathing in nasty fumes while this is running. Assuming that we can trust the readings coming out of this, which may not be accurate of course, it looks like it's done a reasonable job of following the temperature profile. It'll be interesting to see what the result is on the boards themselves. And that is really annoying. That's, I wonder if we can stop this. It's got S for stop. Okay, so that just disables the fan. I don't know why that alarm went off. I think it was just because it fell below 100 degrees. Maybe it's telling us that the job is done. The temperature is actually still fairly high though. It's still, you know, in the 80 to 90 degree region. And I had to hit S to silence it, or stop it. It'd be nice to be able to just acknowledge or silence that and let it continue its cool down process. So I'm just going to let it sit for a minute and then we'll open it up and see what the boards look like. Now I've turned the whole thing off to stop the all the noise. Slide it out. The handle is kind of hot. and we'll see what's happened to these boards. See whether they've got scorched, in which case it got too hot, or if there is unreflowed solder, in which case it didn't get hot enough. Well, all of the boards look the same, which is a very good sign. This is just an example from down in the bottom right corner. There is a little bit of pooled solder on these two pads where I put solder paste on but no part. The diode is nicely soldered, and the two 0603 parts there seem to be soldered well as well. So overall, this has given me a really nice result. Now, as a slightly more ambitious test, I'm going to run through some of these mini panels. These are power over Ethernet regulator modules, just on little mini panels that would, as they go through a pick and place machine with the slide rails. So I've populated some of those by hand, put those through, see how it goes. Well, once again, I'm very happy with the result. There were only a few parts on this board. It's just a carrier for a DC-DC converter module. But even so, I can tell it's done a pretty good job of it. So I'm really happy with this oven. Well, my summary is that so far I really like this oven. It's a really big step up from the little toaster oven with the Arduino controlling it with the PID profile. Also, I should mention different models. This is actually a pretty large unit. The company that makes this, and if you look on AliExpress or eBay or whatever for reflow ovens, you'll see that probably the most common model around is the T-962A. There was originally the T-962 and then the 962A came out. I'm not sure what the difference is. I think maybe they added some heating elements. It's like 4 elements instead of 2, so that it would be able to get the temperature profile to follow the curve more accurately. And the 962B, well sorry, the 962A is probably about half this size. It's got a much smaller drawer on it. That's the really common one. This is the 962C, which is the largest of the desktop units. Costs probably 2.5 times as much. This one cost a total of about $650 Australian, including DHL delivery to here in Australia. And I ordered it and it arrived about 4 days later. So you can get the little ones, the 962As, for like a couple of $100 with some shipping. They're fantastic value. This one seems to be really good though. I like it. And it will let me put fairly large runs of boards through at a time. Should be fun. See you next time.